Today's lesson on lesson 3.3 is on solving linear systems algebraically. So our last lesson we talked about how do you graph two lines and figure out that point where those two lines meet, and so that was our solution to our system of equations. Algebraically, we can find that point xy where those two lines meet, and we can do that in a couple of different methods. One of those methods is called the substitution method. So the substitution method says that we are going to substitute an expression into one of the equations. And solve for the variable. And I'm going to say solve for a variable because we're not going to be able to find both of them, but we can certainly find one of them and then do a substitution of that value back in. We'll go through what that means in just a moment here. So to substitute, again, you guys think about the word substitute. Substitute teachers are replacements. All right? And so if you think about substitute as making a replacement, we're going to replace a variable with an expression and then solve. Elimination is exactly what it sounds like. We're going to eliminate one variable as a means of solution, or as a way to solve. And again, as we get into the instructions here, this will make much more sense as you look at some more examples. So, substitution method says we're going to make a substitution. Elimination method says we're going to do some eliminating. All right, so let's get right into our first example. Let's first talk about the substitution method. The substitution method says solve one of the equations for one of its variables. So that means we need to make one of the equations either say x equals or y equals. Some expression in terms of x or y, but it has to say x equals or y equals. And then we're going to substitute the expression that we made from step 1 into the other equation and solve for the other variable. And again, this will make much more sense as we start to make some substitutions. If you have an equation in two variables like 3x plus 2y is equal to 10, you can't solve that equation for one variable, at least one value of a variable, but you can solve it for an expression. We'll get into how to do that in just a moment here. All right? Substitute the value from step number 2, the value that we got up here, into the revised equation from step 1 and then solve for the other value. So again, we're still looking for that x and y. We're still looking for that point, but we're not doing it graphically this time. We're looking for that xy solution, and we're going to do so in an algebraic way. All right? So the first thing then was we're going to talk about a problem involving substitution. It says we're going to solve this system of equations using the substitution method. So here's our system. You'll notice that the first equation, it's not exactly solved for x or y, but man, since we've got one x here, we can really easily solve this thing to make it say x equals. In fact, if I just take x plus 2y is equal to negative 2, and I minus 2y from both sides of my equation, keep in mind that this is now x equals negative 2y minus 2. It is not negative 4, all right, or negative 4y. You got to keep your y's and your constants. You got to keep your variable terms and your constant terms separate. So we can either have negative 2 minus 2y or negative 2y minus 2. I don't care. It totally doesn't matter. But now we've solved equation 1 so that it's only in terms of y. We've made it say x equals. So if you'll take a look at this second equation now, in our second equation, we have 3 times x plus 4y is equal to 6. Well, if this system of equations is looking for that same value of x and y, and again, I have no idea what these two lines look like, but I'm looking for that x, y that they have in common. So that means the x and y that I have to have is the same x and y as a solution for both of these equations. So what I'm going to do is I'm going to replace, in the second equation, I'm going to replace that x with the expression that I found for x in the first equation. So the first equation I solved for x and made it say x equals this. And now I'm going to rewrite the second equation, 3 times x, well, x is negative 2y minus 2. So again, I'm substituting or replacing the value of x with what x is. And that's that expression, negative 2y minus 2. The rest of it doesn't change. We had 3x plus 4y equals 6. Now I have 3 times what x is, which is negative 2y minus 2, plus 4y is equal to 6. Now, some algebra here we have to distribute. All right, and so I'm going to do that over here. We get negative 6y minus 6 plus 4y is equal to 6. All right? And once we get that, we're going to combine like terms. Negative 2y and positive 4y is negative 2y. A lot of 6's in this question. Add 6 to both sides to get rid of the negative 6 on the left. Negative 2y is equal to 12. And divide both sides by negative 2. And I get y is equal to negative 6. Now, it might seem like we're all done with that question, but we are not even close. All we've done is we found the y value where these two lines meet. Now, obviously, my picture's no good because the y value where they cross is negative 6, so it's down here somewhere, actually. But that's okay, just the visual helps to recognize. Now we have the y value for where those two lines meet. Now I have to find the x value. So equation number 1, we've already solved equation number 1 to make it say x equals. So we're just going to say x is equal to negative 2 times the value of y that we just solved for. So once again, we're going to make a substitution, minus 2. So again, the expression for x was negative 2 times x minus 2, and we just replaced the x, or I'm sorry, the y, with what y was. So negative 2 times negative 6 is positive 12. 12 minus 2 is 10, and so my solution is the point 10, negative 6. Now once again, I have absolutely no idea what these two lines look like, but I do know that those two lines are going to intersect somewhere in the neighborhood of 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, somewhere down in here. And again, they could look like this and like this. I have no idea. But they cross at that point, which is 10, negative 6. All right, so the next idea then is this idea of eliminating. So we've done a substitution problem. Let's talk about eliminating. As we said before, elimination requires that you eliminate one variable. Sometimes the coefficients won't just add together and cancel out. So the first step then is going to be to multiply one or both of the equations by some constant to obtain coefficients that differ in sign. Okay, they could have the same sign or they could have different signs. It's better if they have one positive, one negative, and we'll talk about what to do to make that happen in just a moment here. We're then going to add the new revised equation from step 1, and when we do that, one of the terms will basically eliminate or cancel out. So we're eliminating one of the variables. And then we're going to solve for the remaining variable. Once we get that, we're going to substitute the value that we obtained in step number 2 into the original equation and solve for the other variable. All right, so wasting no time here, let's get right to example 2. Using the elimination method, you'll see here that essentially these two, well, they're not the same value. They're certainly not the same value. But, you know, if I doubled the first equation, I could get double this whole thing. Now again, when I double, I have to double the whole thing, both sides, left and right. But if I doubled this would become 4x, which then would match this one. And now I have the exact same number of x's in each problem. So, as we said before, we want them to differ in sign. So actually what I want to do is I want to multiply the whole first equation, every single part of it, left side and right, by negative 2. And you'll see why in just a moment. Multiply the entire equation, number 1, by negative 2. So again, we're just going to say this equation times negative 2. And so if I do that, I get negative 4x. I get plus 5y. I get equals, sorry, I don't get 5y. Let's back that up a little bit. I get negative 4x minus 10y is equal to negative 28. Because again, I'm going to multiply 5 by negative 2, 14 by negative 2, and 2 by negative 2 and get that equation. The second equation, we don't need to change that because already you can see that these x's will match. So I have the same number of x's in both problems, but they're different signs, which is perfect. Now if I just add down the columns, what's negative 4x and positive 4x? Well, conveniently, those cancel out. And that's what we wanted. We wanted to eliminate one of the variables, which we've done. There's our elimination. So now negative 10y plus 2y becomes negative 8y. And negative 28 minus 4 more becomes negative 32. Dividing both sides by negative 8 tells you that y is then equal to 4. All right. Now we're going to take that value of y and we're going to substitute it into one of the equations. It totally doesn't matter which one. You could use equation 1 or 2. We happen to take equation number 1. The original equation 1, again, you can use the revised equation 1, you can use the original equation 1, or the original equation 2. Doesn't matter which one you use. Any of this one, or this one would be just fine. So we take the original equation 1, and I say 2 times x plus 5y is equal to 14. So I rewrite the equation. And now I'm going to replace the y with what y is. We just solved for it and said y is equal to 4. So this becomes 2x plus 20 is equal to 14. Subtracting 24 from both sides yields that 2x is equal to negative 6. And if I divide both sides by 2, I get x equals negative 3. So the x value is negative 3. The y value is 4. Don't just put them in the order that you solved for them. Make sure you put the y in the second place because that's the second number, and here's your x there. Now, you could graph these two lines and check. That's what they ask you to do here in the instruction. They say graph them both, but that requires you change them both to y equals mx plus b to plug them in your graphing calculator. You know, probably not a great option. Again, you could graph them like we did last time and graph by using the intercepts as well, and you should yield about the same solution, negative 3, 4. The best way to check those two solutions, the x and y, is to plug them into the original equations. 2 times negative 3 plus 5 times 4 should be equal to 14. And 4 times negative 3 plus 2 times 4 should be equal to negative 4. And I'll let you guys do the math on that, but this does check, and this one also does check, and so we know it's the right solution. All right. So, top of the next page, there are 2 checkpoint problems that I'd like you guys to try. Please pause your video and actually try them. The first one they want you to do substitution. The second one they want you to do elimination. Pause your video, try the 2 problems, and we'll be right back with a solution. Okay, so equation number 1 is not written in the form where y equals or x equals, but man, this says y here. It's just 1y, so that's perfect. This one is set up very nicely to simply subtract 2x from both sides of the equation and solve for y. And so this becomes y equals negative 2x minus 2. So we've now rewritten the first equation so that it's in terms of y only. So y is equal to this expression, negative 2x minus 2. So then we're going to rewrite the second equation, 5x plus 3 times what y is. Well, if you remember, we just said y is negative 2x minus 2. So we're going to replace the y with negative 2x minus 2 is equal to negative 8. And again, realize that all I did was rewrite this equation right here, and I replaced or substituted the y that I found here in equation number 1. Okay, go ahead and distribute. This is 5x minus 6x minus 6 is equal to negative 8. When I distribute the negative 3, I get negative 6x and negative 6. From there, we combine like terms, so this is just negative x or negative 1x, however you chose to write it. Add 6 to both sides. And I get negative x equals negative 2, so therefore x is equal to 2. This is not done. All we've done is found the value of x. So we know the x value where the 2 lines meet, so we also need to find a y value. You can plug this x into this equation, you can plug it into this equation, or you can plug it into this equation. It doesn't matter. Any of them are going to give you a value of y. Now since this one's already solved in terms of y, I can simply say y equals negative 2 times x, which we said is 2, minus 2. And again, I apologize for all the 2's there, but this 2 right here is the x that we found in this step over here. Negative 2 times 2 is negative 4, minus 2 more is negative 6. And so the solution for this one is the point x is 2, y is negative 6. The next one wants us to do elimination. Now, there's nothing we can multiply a 3 by to make it a 2. There's nothing we can multiply a negative 2 by to make it a 3. We could double this one and we could multiply this one by 3 and get them both 6's, but why not pay attention to the y's and recognize, man, if I just multiplied this second equation by 4, then these would both be 8y's, and we'd have the same number of y's in both problems, and then they would cancel out. The first equation I'm going to leave exactly the same, 3x plus 8y is equal to negative 5. And I'll tell you guys, it's going to take a little practice with this. The more you practice this, the easier it is to figure out what you're multiplying by. In any case, the second example, the second equation, we actually want to multiply by negative 4. Now again, you might say, well, why negative 4? The 4, because we want the 2 times 4 to give me 8 to match, and the negative, because we want them to be opposite signs, so they will do what? If you said eliminate to yourself, you're doing things the right way. Multiply this second equation, the whole thing, by negative 4. Negative 2 times negative 4 becomes positive 8x. 2y times negative 4 becomes negative 8y. And 18 times negative 4 becomes negative 72. From there, take a look, see what happens. Y's will eliminate, and you get 11x is equal to negative 77. Divide both sides by 11, and you get x equals negative 7. Alrighty, so Now we're going to take a look at a couple more examples. What happens when we can't multiply just one equation by something? Well, what we do in this case now is we're going to choose to multiply both equations by something. So we're going to go ahead and we're going to multiply the first equation by 5 and the second equation by 3. They already have different signs, so if I just multiply this one by 5, this becomes a positive 15. And if I multiply this one by 3, this becomes a negative 15. And so I have 15x and negative 15x, which are going to eliminate. So if I multiply the first one by 5 and the second one by 3, this becomes 15x minus 20y is equal to negative 185. And the second equation we're multiplying by 3 is negative 15x. This is plus 9y is equal to 42. Now, these are already opposite signs, so when I add them, I get 29y is equal to negative, oops, I'm sorry, that's not 29. This is negative 20 and positive 9, so apologize. Let me slide that over here. This is negative 11y is equal to negative 143. And dividing both sides by negative 11, you get y is equal to positive 13. Now I have my value for y, so I'm going to choose one of the equations. We just happen to choose equation 1. You can choose any of them. 3 times x minus 4 times 13 is equal to negative 37. And then let's do some algebra over here. 3x minus 4 times 13, that happens to be 52, equals negative 37. I'm going to add 52 to both sides. All right, and when I add 52 to both sides, I get 3x is equal to 15. And when I divide both sides by 3, I get x equals 5. So my solution is 513. And again, you can check that solution algebraically, or you can check it with a graph. All right, so our last idea then is this. What happens when all kinds of stuff goes haywire here? What happens if, when I start getting rid of things, everything cancels out? Let's take a look at example number, or letter A here. Taking a look at the coefficients in this particular example, if I multiply the entire first equation, it says because the coefficient of x in the first equation is 1, that means substitution is probably a good way to go. So if I add 3y to both sides in this equation, I get x equals 3y plus 7. And now I'm going to substitute that in right there. This becomes 2 times 3y plus 7. And go ahead and distribute. I get 6y plus 7 minus 6y is equal to 12. And when I do that, the 6y minus 6y cancels out. And so I get 7 equals 12. The statement 7 equals 12 is never true. So because the statement is never true, that means the two lines never cross. That means there are no solutions. Or rather, there is no solution. I guess I should use proper grammar there. There is no solution. There is no one point because the two lines must be parallel. All right? The second example then says, look, let's take a look at the coefficients. Neither one of the coefficients is 1, so we probably want to go ahead with elimination here. When I do elimination, I'm going to go ahead and multiply the first equation by 5 and the second equation by 2. All right, if I multiply this one by 5 and this one by 2, this is going to become 10x minus 30y is equal to 60. And the other equation is going to be negative 10x plus 30y is equal to negative 60. Well, wait a minute. We did that 5 to get these to be opposites, but the x's and the y's all canceled out, so I get 0. And over here, I get 60 minus 60, which is also 0. So the equation is 0 equals 0. That's always true. So that means that every solution on the first line, every xy that's on one line is on the other line. These two lines are one and the same. This is one of those consistent dependent systems. This is one of those that has there's infinite number of solutions. There are an infinite number of solutions. This system is consistent and dependent, as we talked about from our last lesson. All right? So as I'm finishing my recording here, the two checkpoint problems, I want you to try them both. I will tell you that the solution for the first one, there are no solutions. And for this one, your solution is negative 4 and 5. Try those two examples. You should get those two solutions. If you're interested in seeing the method on how we do that, we will start class with that on our next day. Hopefully that went well for you and you've taken good notes for that. I will see you guys tomorrow.